So the overarching idea of a substitution reaction is that you're substituting one thing for another. So here we have a molecule with substituent X. And then by the end of the substitution reaction, we've replaced it with molecule Y. So that's kind of the overarching idea. Now we're going to talk about the possible mechanism steps and the mechanisms of substitution reactions. So not all of these are going to happen every single time. If you have the most complicated substitution reaction ever, you would have them in this order. You could possibly have a proton transfer first. However, that's not always going to be the case, but you are always going to have the loss of a leaving group. In every single substitution reaction, this step will happen. The next one is a carbocation rearrangement. Again, this will not always be the case, but number 4 will always happen. You'll always have a nucleophilic attack in a substitution reaction. And then you could possibly have another proton transfer at the end of the reaction. However, this is not always the case. So within substitution reactions, you have 2 major classes of them. You have SN1 reactions and you also have SN2 reactions. They are very similar, but the way in which they happen is very different. So we're going to do, again, just an overview, a little comparison of the 2, and then we'll have specific videos for just SN1 and just SN2 details. So the first thing to note is that in an SN1 reaction, the 2 main things that we said would happen, the loss of the leaving group and the nucleophilic attack, those are going to happen one at a time. You're always going to have the loss of leaving group before your nucleophilic attack. This is not saying that there can't be steps before or between these, but you're always going to have the loss of the leaving group before the nucleophilic attack. And what this means is that you always need to check for a carbocation rearrangement. So let's talk about this. If you have a molecule and our leaving group is this chlorine right here, and we said that the loss of the leaving group has to happen before the nucleophilic attack. So we know that our leaving group is going to leave. When that happens, you are taking away a bond from this carbon right here. When you take away a bond, you're giving that carbon a formal charge. So every time you have the loss of a leaving group without something replacing it at the same time, you're left with a carbocation. And when you're left with a carbocation, you need to check to make sure that it is stable. In this case, it's already tertiary. We would not need to do a methyl shift or a hydride shift, but this is something that you need to look for because in some cases you could move it to a more stable position. The major difference with the SN2 reaction is that your loss of leaving group and your nucleophilic attack happen at the same time. So this would be called a concerted process. So we have the loss of the leaving group and our nucleophilic attack, this just says nuke for short, happening all at the same time. And how do I know where this nucleophile attacks? It's going to attack the electrophile. There's another video on nucleophiles versus electrophiles if you want to go back and reference that. But our nucleophile is going to have free electrons to come and attack an electrophilic center. Because this chlorine is more electronegative than the carbon it's attached to, that's giving the carbon a partial positive charge. And because that carbon is partially positive, it's a good electrophile for that nucleophile to come in and attach itself to. So because all of this is happening at the same time, we're never going to be left with a carbocation like we did for SN1. So we don't need to check for a carbocation rearrangement. So these are the basic overarching differences between the two. There are several more differences between SN1 and SN2 that weren't covered in this video, but I do have specific videos for SN1 only and for SN2 only that should cover a lot of the questions you might have.
I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.